Hello friend, welcome to Data Laksh. In this video, we are going to discuss a problem from the machine learning based on the overfitting and underfitting for the GATE DA paper. The question here say which of the following conditions typically indicate overfitting in supervised regression. The given options here low training error and high test error. Next option is high training and high test error. And third option is large model complexity with the many parameters. And last one is under regularized model here. So before going to answer these options, now let us see what is overfitting and underfitting. So as we know, in case of the machine learning model is based on the training and testing on the data set. So its performance we can see here. So machine learning model aims to perform well on the both training and testing data. So as we know, we have two type of in case of machine learning, we work with the two data. One is the training part, training data, and second one is the testing data right here. And we check the model performance on the both training and testing. So here if the model as it's a machine learning model aim to perform well on the both training data and new data, that is unseen data, and is considered to be good or good fit if it learn pattern effectively from the training data. Also it generalizes well to new and unseen data, and it avoids memorizing the training data. So in case of memorizing, it should be uh, in case of the memorizing, it should learn from the data. So it should avoid the memorizing the training data, and this case happen in case of the overfitting or failing to capture the relevant pattern. So this case happen in case of underfitting. So these cases we'll see the in next slide. So if you see this picture here, so we have these data points we have, and our model learn very well with the this data set. So this is like a curve point, and it learn the very well with the data set. So this is the case of good fit right here. And what it say further to evaluate how in case of evaluation, to evaluate how a well model learn and generalizes, we monitor its performance on both training and a separate validation, or also known the test data right here, which is often measured by its accuracy or prediction errors here. So its performance checked on performance checked on what both training as well as testing data right here, and we check further its accuracy and prediction error. However, we can achieve a balance. However, achieving this balance can be challenging here right here. Now let us see the next case here. uh, Before going to see the next is overfitting and underfitting. So these are the two common issue in case of the model performance we observe here. One is the overfitting and second is the underfitting. And these problem are the major contributor to poor performance in the machine learning models here. So here we have two key term related to understand the overfitting and the underfitting. One is the bias and second is the variance. So what is the bias? It is the error that happens. So this is the error that happens when the machine learning model is too simple and does not learn enough detail from the data. And this representation, that means if the bias is high, so this case arises for the underfitting. And what is the variance? This is also error that happen when the machine learning model learn to the too much from the data, including the random noises right here. And here is the if the variance is high, so this case arises for the overfitting. So next we have overfitting here. So what is the overfitting in the machine learning? So overfitting happen when the model learn too much from the training data, including the details that does not matter. So if, for example, noises are the outlier, that means we don't need to, we don't do not expect machine learning, or we do not expect model to learn outliers or the noise, but you also learn from the noises and the outlier. So in this case, it will perform the poor. So that is here the overfitting case arises. So if you see the picture here, that we have this data point, we have and the model go from the each data point for like this, and instead this should be like in case first case we have seen the uh, parabola. Sorry, in case of the curve type right here, but here this is the it go from the each point. So this is the case of the overfitting. So for example, imagine the fitting a very complicated curve to set of points, and the curve will go through the each and every points, but it will not represent the actual pattern. As a result, the model worked great on the training but fail on the test on the new data. So it performed the well on the training data, but uh, in case of testing it fails. And overfitting model are like a student. So if you compare with the any student, learning student, that means a student who memorize the answer instead of the understanding the topic. And in that case, if he memorize or she memorizes the answer, that means he or she will be able to perform the on the practice test, but she or may struggle to in the real exams. That is in case of testing. So what may be the reason for the overfitting? So overfitting typically arises from the high variance and low bias here, and excessive model complexity, and an inadequate amount of training data. So if the amount of data is also inadequate, that also may result with the case of the overfitting. Next is the underfitting. Right here we have underfitting in machine learning. So underfitting happens when a model is too simple to capture what is going uh, in the data. For example, imagine a drawing a straight line to fit that actually follow a curve. So as we know, this data point follow a curve, but the model learn like a straight line. So this is case for the underfitting. In this case, the line misses the most of the pattern. So this line miss the actual pattern. And in this case, model does not work with well on the either training or the testing. So it failed with the both testing as well as the uh, training data. Underfitting model like the student who do not study enough, and in that case they don't do well in the practice test as well as the real exam. And what is the reason for the underfitting? So the reason here the model is too simple, and so it may not be capable to represent the complexity in the data, and the input feature which is used to train the model is not the adequate representation of the underlying factor influencing the target variable, and the size of the training data used is not enough. So here uh, training data may also be not enough for to get the right pattern, and the input feature also used in the training model not the adequate representation. Now let us come on our actual topic with the related question. The question is which of the following condition typically indicate the overfitting in the supervised regression? So first option is what it's a low training error and the high test error. So in this case, as we know, when the model fit the training data too well, so with very poor training error, but perform poorly on unseen data set. That is the high test error, and it indicates overfitting. The model has memorized the training data instead of the learning the general pattern. So this is the true. with the case of overfitting right here. So this is the true case. And second option say high training error and the high test error. So this is the false as it is the for the case of underfitting, not the overfitting here. So this is the false option. Next is large model complexity with the many parameters. So this is also true as large model complexity. For example, too many parameters, deep tree, high degree polynomial often lead to overfitting because the model can capture noises also as if it is were a pattern, as we have discussed in the definition in case of overfitting. So this is also true. Next is under regularized model here. So this is also true as an under regularized model means weak or the no penalty on complexity like low lambda and result the loss regression, and it allows parameter to grow large and overfit the data here. So this is also true. So from the given option we can say A, C and D is the true options. So that's it from this video. If you find this video informative, please do like, share and subscribe this channel. Thanks for watching.